Hi everybody, it's Paul again, and this time we'll be looking at how data analytics fits into the business context. So the first thing we need to do is understand what the business context is. So different industries have different kinds of problems and different kinds of ways of working. Within that business context, we need to more strongly frame a business question that we want to answer. So one example of a business question that we might want to answer is, what are the different kinds of customers that we deal with? So notice that that business question is talking about words that have to do with the business, customers, what different types we have. It doesn't talk about data analytics kinds of things like supervised or unsupervised learning. Once we've got our business question, and it can be quite broad at this stage, we want to translate that business question into a data analytics question. The data analytics question is just that first question rephrased into something that uses data analytics words. So as an example, our question was, what kind of customers do we have? And we can translate that into cluster the customers into different groups. We're using the word cluster because that's a word that's related to data analytics. Next thing we need to do, now that we've come up with our data analytics question, is we want to collect some data, and we might do that from the business, and it could be in different spots and needs to be put together, and it could possibly be externally. So there's a whole lot of companies that you can buy data from different data providers. So we've collected our data, we need to understand it, and we need to process it, and we need to put it together and get it and work out what it means. The next stage is to, now that we've got our data and our question, we want to build some models to try and solve that data analytics question. And we need to evaluate the models. And we'll be looking at a lot of this throughout the rest of the session. Now, the models that we've built might answer our business question, or perhaps they don't answer our business question. If they do, great, we're finished. But if they don't, then we need to maybe modify the business question and change it slightly to make it more focused. Regardless, so we may go around that loop many times. Eventually we get to a stage when we have answered our business question, and now we need to deploy the model and the results in the business so that we can act on it. Because remember, we're looking for actionable decision making. And deploying could be done in a number of different ways. we could be just writing a report or doing a presentation, or it might be more complex. We might be developing some software that needs to run every day or something like that. So here's a schematic to just give you an idea of how it fits together. We start on our left with our customers. We build some mathematical models. I show only one here, but it would probably be several. And our mathematical model might do, say, the bottom one. It might find relationships between rows in the data set, so customers, or it might find relationships between attributes about the customers, and that's often called association rule mining. And if we do that, we may find some customer groups. So that's an example of an unsupervised approach. We're just trying to make sense of the data. The other example, the one on the top, we might be trying to predict the class of unseen rows. What I mean here is that we may have some customers, and the problem might be, can we predict which of those customers will respond positively to an advertising offer or not? There we have some data and we're trying to make a prediction for the future, and that's an example of supervised methods. So remember, we've got our unsupervised methods, we're just trying to make sense of the data, and our supervised methods, we learn a relationship between the inputs and the thing we're trying to predict, the output, and then for new data we can predict the output. So going back to the example again, the top one, predicting class of unseen rows, it's a prediction, so it's supervised machine learning. And the bottom one, finding relationships between data points, rows and customers, that's an example of, we're not trying to predict anything, we're just trying to make sense of the data, so that's an example of the unsupervised approaches. So I want to just go through some examples of different kinds of things. The first one here is an example from gambling. So the problem here is for the New South Wales TAB, this is the gambling agency, they want to look for betting patterns. So the approach that they used was the data miners would look at factors such as the track conditions, so they're looking at horse racing, the weather, the number of horses running, and the odds placed on the favourite in each race, and then how they influence the betting. And the method they used in this example was neural networks. And to deploy it, they wanted to find, or they found more accurate predictions on the level of betting on any particular day. And as an example of the kind of model that they might have discovered, the example is if the track is known to be wet, then turnover is up 10%. Let's look at what makes a difference to businesses. So back in the old days, we had online transaction processing, and based on that, we got a lot of data going into data warehouses. So something that will make a difference or a positive difference for businesses is to try to understand what's happening in their business in terms of this data. Again, this is a making sense problem, so it's unsupervised. Even better, once we understand the current business processes, we might want to improve those business processes. And this may be a supervised approach, so trying to make predictions, but it might be an unsupervised approach. So in terms of the data, there's a whole lot of different characteristics that data has. And we're going to look at this over the next few weeks, but just to give you a bit of a heads up on where we're going, we have each entity, so an entity is like a customer or a patient or whatever, is described by 10 to a few hundred features or attributes. A feature is the same thing as attribute, at least in this context. And these are things that we know about the customer. So it might be their name, might be their address, it might be their age. That said, in methods like bioinformatics, where you're trying to apply machine learning in a biology context, or in image processing or in text, you can have thousands of features. You often have different types of entities or multiple entity types. So, for example, customers, patients, doctors, transactions. And as an example, the Health Insurance Commission may have pathology data. So they may have 12 million transactions per year. They may have 80 different pathology laboratories, 20,000 doctors, and 4 million patients. So the numbers can be quite large. Why do we want to add value to the data in terms of understanding it and using it to make decisions? Well, knowledge is power, so it can give a business a competitive edge in the business environment. Adding value to data can improve the knowledge to allow for better decision support, so we can make data-driven decisions. The data is sitting on the disk, so there's all of these volumes of data that maybe hasn't been explored. So there's a lot of information in there. So can we exploit it to produce positive benefits? The data sources are accessible, so we're collecting the data. There's massive data warehouses, and there's available data mining, machine learning tools, and computational power. So why not apply these methods? So you hear the term data warehouse from time to time. The idea of a data warehouse is it's just an organization-wide centralized repository of data, plus a whole lot of data models that say how the bits of the tables relate to one another. There's a thing that's often associated with data warehouses called online analytic processing. It's called OLAP. And this is some fairly basic kind of, I would say it's the beginning of data mining. And with OLAP, you can access these big data warehouses and you can build statistical summaries and you can do some basic analytical modeling. You can build and cache fixed cubes of data. We'll see this a little bit later in the next few weeks. And we can restructure the data to be able to analyze it more efficiently. We can do a fast summarization and aggregation at different levels. Now you can do a lot of this kind of thing in Excel these days. So in Excel there's a thing called pivot tables, and that's essentially this summarization and aggregation of data. There's an interesting idea that comes from artificial intelligence and knowledge discovery, and this is there's different levels of data, information, and knowledge that give you different amounts of understanding. So when we talk about data, we usually talk about raw uninterpreted facts. So, for example, Tom, 20 years old, student. They don't really go together. They're just out there. The next level up is information. So, information relates items of data together. So, for example, Tom is 20 years old. The two bits of data, Tom and 20 years old, are now together. They've been related together. So, we've got information. The next level after that is knowledge, and it relates items of information together. So we can say something like, the fact that Tom is 20 years old implies or infers that Tom pays more than $1,500 insurance. So we've got those two bits of information, and now they've been linked together. And what we do with modelling is try to generalise those ideas of knowledge. So instead of Tom being 20 years old means that Tom pays more than $1,500 insurance, we want to generalise it for people other than Tom. So we can say something like, if someone is 18 to 25 years old, then the probability that they have an accident is high. Now it doesn't relate just to Tom, it's more general. There's a business intelligence view of data analytics and data mining that we can see in this scheme below. So we start with a business problem, we transfer that into a data mining problem, and we saw that. We do some data mining to identify patterns, and then we can use those patterns as business intelligence. And you can see that these two red lines, that's the edges of where the data analytics fits. So outside of those, we're in business land, we're talking about a business problem or business intelligence, and we transform that into a way that we can deal with in data analytics and data mining, and that happens inside. It's a little bit like when we're writing software. So when we're writing software, we take our requirements, which are in business land, and we do some testing, which is in business land. But in between that, we've built a design that abstracts those ideas into a way that we can build with software engineering tools. It's the same thing happening here. The business problem is talking, and the business intelligence is talking about the ideas from business, and we transform those into a way that we can deal with it regardless of the type of business, and that's the data mining problem and patterns. And the data mining takes ideas from a whole lot of different areas. So it takes some ideas from data warehousing, it takes some ideas of just data in general and information visualization. It takes some ideas of different methods and frameworks, and at least in the business intelligence view, it looks at some knowledge discovery techniques. The knowledge discovery techniques are really, we'll be looking at them over the next few weeks, they're really the unsupervised and supervised machine learning methods. And the last thing I wanted to show you is this CRISP-DM view. So CRISP-DM stands for Cross-Industry Standard Process for Data Mining. And it's a methodology that was developed in the early 90s on how to do data mining, how to solve data mining problems. And it's the one that we'll be using in class this semester. And I think you'll find that it's quite nice. We're going to be going through this a lot more in next week or the week after. But essentially there's 6 phases. We start with business understanding. That's where we ask the business question. We move to the data understanding. We do some data preparation and modeling. We might iterate over that a few times. And eventually we do some evaluation. Has it solved the business question? If not, we go back around the loop again. Otherwise, we go to the deployment. So you can see it's a bit similar to what I was talking about earlier. Anyway, that's it for this session. We'll talk about the next one later.